Topic 1 is about measurements. The upper left-hand corner here, you'll see all the different things that you need to know about measurements in topic 1. So let's get right to it. The first point that you need to know from topic 1 is about units. And these are split into two. We have fundamental units and we have derived units. Okay, so all the fundamental units include the meter, kilogram, second, the ampere, the Kelvin, the mole, and the candela. So the candela is a measurement of light intensity, and the mole is just the amount of atoms. Those are the only two that I think should be perhaps surprising if you haven't taken chemistry. 1 mole of atoms is equal to a special number 6.02 times 10 to the power of 23 atoms. This is called Avogadro's number. You'll do it if you take chemistry. The ampere we will get back to because this is the only one that seems to be an issue for most students. All the other ones are just basic units. Meters for distance, kilograms for mass, seconds for time, Kelvin for temperature, and then the other two. Now, derived units are units that use fundamental units to create other units. So, for example, if we have force, the equation is mass times acceleration. Force is measured in newtons. This is a derived unit. Now, this is made up of fundamental units. So we've got the kilogram for mass and the meter per second square for the acceleration. So the newton is a derived unit, and 1 newton is 1 kilogram meter per second square. Okay, so we can use another example here. Kinetic energy is 1/2 mv squared. So the derived unit is a joule. That's what energy is measured in. And a joule is a kilogram meter square per second square, right? Because the speed is meter per second, okay? And so we square that, we get a meter square per second square. And we could do this for others. We could do one more example, a more complicated one perhaps for power. Is the amount of energy per unit time. The unit of power is watt, which is a joule per second, right? So the joule is the unit of energy, and so time, second, so joule per second. Now we know that the joule, just judging by what we have above, is the kilogram meter square per second square per second. So the watt would be that kilogram meter square per second cube. That divided by seconds, so meter square per second cube. So the watt is the derived unit, and it is derived from kilograms meter squared and seconds cubed. Okay, so I said that we'll go back to the amp, because the amp is the strange one here. Seems like meters, kilograms, and seconds, there are no other units that are more fundamental. And the ampere doesn't seem to follow that rule because the ampere, so if I just get a different color here, the ampere is the unit of current. So if you remember your equation for current, current is the amount of charge per unit time. And so the unit for current is the ampere, which is a coulomb per second. The coulomb is the unit of charge, the second is the unit of time. And so it would seem like the coulomb is the fundamental unit, but in fact the ampere is defined as the fundamental unit. So that's just the only one that you have to keep in mind. Okay, so that's that for fundamental and derived units.